Welcome to Elastic Compute Cloud, EC2. Elastic Compute Cloud, two C's, Compute Cloud, EC2, get it? Kind of very similar to Simple Storage Service, S3. And here they're doing the same thing with the two C's for EC2. Now recall, EC2 is the second service that AWS launched in the summer of 2006. First service was S3, second service was EC2. Now what is an EC2? It's essentially a pay-per-use scalable platform for hosting virtual machines. So you pay for whatever you use. It's a platform that they give you that hosts, for the most part, virtual machines. Now, AWS calls VMs, virtual machines, virtual servers, they call them instances, but you get the picture. It supports Windows and Linux instances, as is the case with most virtualization platform for that matter. While this is a cloud platform, it still has an underlying hypervisor. And in most cases, Windows and Linux are the prevalent operating systems that are supported. It is based off of Amazon Machine Image, otherwise known as AMI. So you've heard me talk about AMI in the past, and you're going to hear me talk about AMI in the future. And it's important to understand that AMI refers essentially to a virtual disk template. It's a template for the most part. It's very similar to an OVA or an OVF, and those refer to the Open Virtualization Format and the Open Virtualization Appliance, right? So essentially an AMI can contain a configuration and a virtual disk that you can then use to deploy a virtual machine from. You can also import and export your own AMIs. Now the thing to note here is that you cannot import or you cannot export Amazon created AMIs, and the reason for that is there are a lot of licensing issues. It could borderline piracy if they would allow you, for example, to export an Amazon created Windows 2012 R2 AMI because they will have their license key on there. So you can import your AMIs if you have AMIs that you've created and you want to import them, or you want to move them between availability zones or between regions, etc. You can do that. You can export and import your own, but you can't export, for that matter, Amazon machine images, AMIs that are created by Amazon. Now you'll also notice, and I'll show you in a second when we get into the demo here, that you can also provision AMIs. There are third-party vendors, Citrix, VMware, etc., that have these AMIs that are available on the Amazon marketplace that you can then use to provision resources. So for example, a perfect example of this would be a Citrix NetScaler, which I've used in several occasions for its global server load balancing capabilities. So you have the ability to deploy that appliance in the AWS cloud off of a Citrix provisioned AMI that's available out there. So it makes things a lot easier. Now, one of the things that I definitely want to cover is a little bit of AWS terminology. Some of this is EC2 specific terminology, and some of this is just AWS terminology that you should be familiar with. Some of these we've already talked about, so you're familiar with, but I wanted to make sure that you have kind of a visual, a very summarized place where you're kind of seeing, you know, what does this terminology really mean, just so that it clicks in your mind. Now, some of you have been introduced to this platform, to cloud, directly via AWS, so a lot of this stuff makes sense. Most of you are probably coming to this from a virtualization background, so some of this terminology might be a little different, so I figured we'd put it in here. Now, EC2 instances means a virtual machine or a virtual server, whichever one you want to choose. Amazon machine images, or AMIs, those can be equivalent to templates, you know, OVA or OVF, that's the Open Virtualization Format or the Open Virtualization Appliance. The Elastic Block Storage, EBS, that's your volume, your hard disk, your virtual disk, however way you want to refer to that. Ephemeral storage essentially means temporary storage. The trick here is that it is storage that's local to the server that is presenting that instance, that is presenting that virtual machine. So think of this as if you had your vSphere or your Zen server or your Hyper-V on the server, and that server had local disk. That local disk would be referred to as ephemeral storage. Simple Storage Service, S3, it's 3 S's, hence the S3. That's the equivalent of object-based storage. That's what the industry refers to as object-based storage. EC2 Compute Unit, ECU. ECU is really interesting. Amazon has since moved away from EC2 Compute Units in favor of vCPU. But what ECU essentially means, it's a measure of EC2 processor units, right? So what it does with EC2, and we're going to get to it in detail in the other slides, but EC2 essentially creates a common denominator. What Amazon is doing here is they are selecting, for example, a particular Intel chipset or Intel model, and they're saying, you know what, we are going to build all of our EC2 compute units based on that. That way, as hardware changes, they don't have to constantly worry about the hardware changes. They have their EC2 compute units. Now, this is kind of a model, again, that Amazon has moved away from. The reason I'm presenting it to you here is because depending on the environment that you're going to walk into, or depending on the environment that you're already into, if they're using EC2 compute units or ECUs to build their environment, or if you're walking into a new environment, or if you're a consultant where you're walking into an environment that is already using this type of calculation, then I want to make sure I'm giving you the right knowledge for you to be able to either maintain that environment or even grow it based on that. The last thing I want is for you to walk in there and not know what an ECU is. Hence why it's here. Although Amazon has moved away from it, I just want to give you that knowledge. Depending on the circumstances that you might find yourself in, you might find it useful. A vCPU is more popular than I really need to explain. It's a virtual CPU, and most of you that are coming from the virtualization world already know that very well. Identity and Access Management, IAM, or IAM as we refer to it, that's essentially a very highly delegated system, right? So when you log into your Amazon Management Console, you go to IAM, and you're able to create users, you're able to create roles, you're able to create groups, you're able to create policies. So essentially with IAM, you have the ability of doing very highly delegated administration down to the object level. So you can essentially assign permissions on any object within the AWS cloud using IAM. IAM is extremely powerful, and it is very, very useful. Again, you're able to create users and assign those users permissions. Better yet, you're able to create groups, assign those groups permissions, because that will scale better, and then just take your users and drop them into those groups. There are roles that are pre-configured for you, or you can create roles with the right permissions, and then you have policies that you can also apply. Elastic Load Balancer, ELB, that's just a traditional load balancer. Route 53, essentially that's DNS. Route 53 is really cool because Amazon has built it from the ground up. It's not a traditional DNS, and is the only system that I'm aware of that has 100% SLA uptime. Whether it's with AWS or anywhere else, none of the other cloud service providers, as a matter of fact, none of the other services will have that level of uptime. So look it up. Route 53 is really cool, and we're going to spend a lot of time on it, but I definitely wanted to highlight the fact that it has 100% uptime. So if you're not using Amazon or AWS for anything except DNS, well, you're getting the benefit of 100% uptime for DNS. And I don't have to tell you the importance of DNS to an environment. If DNS goes down, no matter what you've done with your environment, it absolutely makes no sense. So this is one of the greatest services that AWS presents us with. All right, let's talk about EC2 Compute Unit, ECU. This was also sometimes referred to as Elastic Compute Unit. So depending on the documentation or whatever you're reading, this could be one or the other. Now keep in mind, once more, this is a concept that Amazon has moved away from, but there's still a lot of customers out there that have based their entire provisioning of instances based on ECU. So I figured we'd cover it just in case you come across it, or you're doing training around something, and your company still refers or still uses ECUs in the computation. So what is ECU? So it's a relative measure of processing power. What does that mean, Eli? So let me see if I can explain this a little further. So it abstracts the CPU hardware changes. That's still not clear. So what happens is, because Amazon is such a massive infrastructure, and because this massive infrastructure is constantly getting servers deployed, right? It's very likely that you're going to get servers that have different CPU speeds and different models, and it will just not be a very consistent way of measuring or even of charging for this computing power. So what the idea behind ECU was to establish a common denominator, a level or a measure of charge that then Amazon could leverage. So if, for example, what they did was they standardized on one ECU is equivalent to 1.0 or 1.2 gigahertz 2007 Intel Opteron or 2007 Xeon processor. Now, sure, this is old processors, right? But again, they've chosen a denominator, right? This is what we're going to base our ECUs on. So when you went to provision virtual machines, instead of provisioning virtual machines based on a virtual CPU, knowing what the actual physical CPU is here, you didn't necessarily need to know what the underlying physical CPU was. You would know that one ECU is equivalent to 1.0 or 1.2 gigahertz 2007 Intel Opteron or 2007 Xeon processor. And then you would do your calculations based on that. So for you, it wouldn't matter what the underlying CPU was. It could be the latest version of the Intel processor, or it could be an earlier generation of the Intel processor. It didn't really matter. Why? Because your calculation is based, again, off this particular standard. Now, this is helpful because, again, you would end up with a server, for example, with 40 ECUs. That 40 ECUs would be equivalent to the processing power that is needed based on calculations that you've done. So it was an easy way not easy. This was a concept that a lot of customers, a lot of us, it wasn't easy for us to grasp, but from an Amazon perspective, this was an easy way for them to abstract all those hardware changes that are happening. It's very difficult to keep up with the CPU changes, essentially, so let alone an infrastructure like Amazon that has thousands of servers that get deployed on a regular basis. So this was the mentality. They've since moved away from that to a vCPU model, and now you know very clearly what the underlying physical CPU that you're running on is. So you can do that the traditional way that you're used to, but I wanted to shed some light on how things were done before. And I'm going to show you where in the management console you can get access to the ECU so that you can see how things were done before. Now, it's a consistent amount of CPU capacity regardless of hardware. We talked about that. Each instance type may be based on different physical processors, right? So again, because Amazon's getting different families of processors, this was a way to kind of completely abstract the hardware, right? You don't really care what's under there. You don't need to know what's under there. All you need to know is that one ECU is equivalent to this particular processor, and you do your calculations based on that. So you can manage consistency through benchmarks and tests. So the idea, or what Amazon was telling customers to do, is, hey, we are telling you that one ECU is equivalent to X, right? Which is what I have on the screen here. Now it's up to you to go through and do your benchmarks and tests. And there are a lot of tools that you can leverage out there to figure out, kind of if you're reaching that benchmark, if you're reaching those test thresholds that you need in order for your application to function properly. And a lot of customers did that and have achieved success with it based on this particular concept. Now, as you get into provisioning EC2 instances, you're going to quickly come up against the idea of an instance type. So what Amazon has done to kind of simplify things is they've created families of instances based on the workload type that you're trying to use, right? So if you have an application that is CPU intensive, they have a family of instances that are dedicated to that. Same thing for memory, same thing for GPU, etc. So let's go through and take a look at the EC2 instance types that are available for you. So for starters, you have micro instances. For the most part, anytime you're dealing with the free tier, you'll notice that a lot of micro instances are available in the free tier. Those are essentially an instance with very low resources, very low compute, very low memory, and it will be used for, again, maybe test, maybe development, or if you want multiple small machines that run a particular task, this might be a good use case. But for the most part, the thing to take away here is this is going to have limited resources. You have then the general purpose. General purpose instances are those that have a good balance of CPU, vCPU, memory, I/O, network, etc. They're going to be equivalent for a general purpose workload, essentially. From there, you move on to a compute optimized. So a compute optimized instance is one that gives priority to the compute, the virtual CPU for that matter, and is specifically designed for workloads that are CPU intensive. So for those, you would probably go with the compute optimized. It will have more emphasis on the compute and less emphasis on some of the other resources. You move on from there to GPU instances, and GPU instances have a lot of use cases, right? I can go on forever talking about the use cases for GPU. I think the first thing that pops into your mind is obviously video rendering, and anytime you're doing 3D stuff, it might be useful for the healthcare environment, might be useful for oil and gas. VDI could benefit from it depending on what you're trying to do. There's just simply a lot of GPU use cases. You could also have workloads that are maybe heavy compute workloads that know how to take advantage of GPUs, that could be another use case for those as well. From there, you move on to memory optimized. That's pretty self-explanatory. For those workloads that are memory optimized, you can definitely leverage those instances. And then you could talk about storage optimized. So for workloads that are going to be intensive on storage or require intensive storage, you can go into some of these storage optimized instances. What I want to do from here is move on to the demo and show you a lot of the concepts and stuff that we've been talking about. From our management console, what we're going to do is click on EC2, and you've probably seen this a few times already, but what I want to start with is show you where the AMIs are. Now, again, you've probably seen them, but let's go through and go through that again. So if I click on launch instances here, you'll start to come across AMIs. These are AMIs that are provisioned by Amazon that are available to you. Now you'll find here on the left that you have the option of, again, if you have your own AMIs that you've created, well, then you can click on it and they would be listed here, right? So again, you can get those from the marketplace, or you can have your own community AMIs, etc. There's a whole list of them that you can get. And you can see here, you can filter it more for those that are owned by you, those that are shared with you, 32-bit or 64-bit platform. So again, there's a lot of options there for my AMIs. You also have AWS Marketplace. So if you go into the AWS Marketplace, you'll find that there are AMIs that are provisioned by several different third-party, for instance. So you can do that. For example, one of the things that I like to take a look at, again, I mentioned Citrix during the presentation. So if you go through and you're looking, see Netscaler pops up immediately. That's a very popular AMI that I've used frequently on this platform before. So this pops up immediately and you can just go through and select the one that you want. So you get the idea of what an AMI is, right? So it's an OVA, it's an OVF essentially that you can use to very quickly deploy your instance, your virtual machine from, and be up and running in no time. A lot of these AMIs can be also combined with scripts, what's known as a CloudFormation, where it's not only deploying the instance, but it's also configuring the instance so that, again, you're up and running in no time. There are community AMIs, and then there are the free tier. So if you wanted to filter those by the ones that are essentially free, if you're just testing things, you can simply click on the free tier, and this will give you a list of all of the free AMIs that you can use. And again, you'll find here that where you can choose the AMI that you want. All right, so let's go ahead and talk about ECU a little bit. Now, what you'll find is if you select a particular instance that you're trying to deploy. So for example, let's go ahead and let's go find a Windows one. Let's select this one, for example. If I select this one, you'll find that in this next window here, there's vCPU, but there's no concept of an ECU anymore, right? But the closest thing that you see for ECU mentioned up here would be up here. So it's showing you that essentially the currently selected has a variable ECU. Okay, well, that's not very helpful. But if you select another instance, for instance, again, it'll give you different things up here depending on what you're selecting. Now, one of the things that I found valuable, if you are used to provisioning stuff based on ECU and you still want to see what this vCPU equals in ECU world, what you can do is up here you can do show height columns, and you have access to stuff that you can show. So if, for example, you wanted to see the ECUs, you can click on that. If you wanted to see the physical processor that it is running maybe under, you can select that as well. If you wanted to look at the clock speed, you can also select that, and those become very helpful, very valuable in terms of more information, depending on how you're used to configuring your environment. If you're coming from the virtualization world and you're in an environment where you don't know about ECUs, ignore it, right? All I want you to do is focus on vCPU. This is the physical processor that it's running against. It's a very similar concept to what you're used to with Hyper-V, with Zen Server, with vSphere, etc. If you are coming from a world that is used to configuring things based on ECUs, well, then you can come down here and you'll start seeing, well, this one vCPU that's running on this physical processor with this clock speed equals 3 ECUs, and you can do your math accordingly. Now, also, you'll find that the particular definition that I gave in my earlier presentation as far as what ECU is basing a single ECU off of is available here. So you'll find that exact definition is here as far as that common denominator of how they're doing their calculations for these ECUs. Now you'll also see that it's also specifying the memory, it's specifying the type of disk. So again, we have instance storage. Can someone tell me what instance storage is? Let me see if you guys have been paying attention up to this point. I'm going to be very disappointed if you can't. Actually, what I want you to do, without cheating, if you remember what instance storage is at this point, I want you to tweak that to me. I want you to stop. My handle is at eKnaser, EKHNASER. I want you to tweet and say, yes, I remembered it. Anyone? If you said ephemeral, then you're absolutely correct. So in this case, you are getting an ephemeral storage. So this instance will be provisioned with local disk on the server that is going to create that EC2 instance. So think about it this way. If this was on your on-premises environment and you have an ESXi server, and that ESXi server is not attached to a SAN or a NAS, it just has local disk, and you created a virtual machine, then this particular disk that you're seeing here is attached to that local server. It doesn't have any other disk. Now, if we scroll a little bit down here, you'll find that EBS is available, right? So if you wanted to attach those alternative volumes that are attached to a NAS or a SAN or something other than disk on the local server, then this machine would probably be, well, is capable of doing that, where the others are not. So the others are all going to be ephemeral. And recall, ephemeral is temporary storage. It doesn't mean that it's slow storage or it's bad storage. It's just a particular use case. It's going to persist when you reboot. It's going to be terminated when you terminate the instance or when you stop the instance. So it's very useful for you to do a lot of things, but just keep those in mind. EBS, on the other hand, everything that you store there is going to persist because EBS is not directly tied to the instance. And what I mean by tied is if you delete the instance, you can keep the EBS volume. Whereas if you delete the instance, you're automatically deleting the ephemeral storage that's attached to it. Now, we also talked about the fact that there are several instance types. There are different families of instances, right? So how do you make that determination? So if you come up here to where it says all instance types, right now what we're doing is we're displaying all the instance types. From the drop-down menu up here though, you'll find that all the instance types that I referred to are available. So if you were interested in, let's say for example, just GPU instances, you can select that and bada bing, bada boom, you'll find that there is a particular instance that's available with those configurations, and you'll find that, for example, it has 26 ECUs, 8 vCPUs. So you can, again, start to figure out the math here based on how they're doing that, again, to figure out this particular one. But again, this one is configured specifically for GPU purposes. So you can use it for video rendering, for healthcare, for oil and gas, any kind of 3D modeling, maybe even VDI, depending on what you're doing with it. There's a lot of use cases. But again, you're able to, again, filter from this drop-down menu here to the particular family that you're interested in based on the workload, based on the application that you're trying to deploy. There's the general purpose, which is going to be the more popular one, and then there's the compute optimized, and you'll find that there are several options there. Now, I'm going to give you another website that's kind of cool that Amazon technically supports, that aggregates a lot of this information, and we'll be referring to that website a little bit later on in other modules as well. But if you go to this particular website up here, cdn.awsnow.info, you'll find that it gives you access to a wealth of information around a lot of the instances. For example, they'll put them side by side. You'll be able to see the processor that it's running on, the architecture of this particular, the instance type. You'll be able to see, for example, how many vCPUs. You'll see the ECUs right next to it, the memory, so on and so forth. And they've even charted this with a pretty graph here that goes sort of horizontally. So for instance, if you go all the way up and to the right here, you'll find, for example, this particular one has 104 ECUs and 244 gig of memory. And you can play around with it. It's kind of a cool website that's very helpful, not just for the instances, but also for billing and some other Amazon services that are out there. So for example, here it's showing you the different regions and which services are available in different regions. So it's a very helpful, handy website for any AWS administrator or architect to have access to. And that's EC2 essentially. Let's switch back to our presentation and recap what we've learned. You know, it's very funny. Sometimes as I'm going through this material, I'm like, I wish I was watching this for the first time. I wish I was learning this for the first time. It's so cool that it's very much outside of what we've done for a long time, right? It's different. And I'm like, man, this is really cool. I wish I was learning this for the first time. So I'm hoping that you're enjoying it just as much as I am recording it. So we started off by talking about Elastic Compute Cloud. And again, it's named EC2 because there's two C's in its name, Compute and Cloud. EC2, very similar to why S3 has S3 because it's storage, simple storage service. Now again, recall this is the second AWS service that was launched in the summer of 2006, and it's essentially an elastic platform, pay-per-use platform to launch virtual machines. It's based on Windows and Linux instances for the most part. The instances are based off of an AMI, an Amazon Machine Image, which is the equivalent in the industry of an OVA or an OVF, which is a compilation. It's an aggregate which allows you to deploy a virtual machine from a template that has settings and virtual disks within it. We then talked about AWS terminology, right? We talked about what is EC2 equivalent to? Well, EC2 instances are equivalent to virtual machines or virtual servers. Route 53 is what AWS refers to as DNS. We talked about vCPU, that's the same. We talked about the fact that ECU is an older method of measuring compute, for instance. We talked about the different terminologies that are available out there that AWS uses versus what the industry is kind of used to. We then moved on to EC2 Compute Unit, ECU, right? That was the older way of how AWS calculated or measured the CPU capacity. And the reason they did that is, again, to abstract all the hardware changes. Because there are always new CPUs on the market, this was a way for them to kind of establish a common denominator and say one Amazon ECU is equivalent to a 1.0 or 1.2 Intel Xeon 2007 processor, and then you would do your calculations based off of that. If you needed 100 ECUs, well, then you would calculate 100 ECUs based on that common denominator. It was a noble idea because, again, it abstracted completely the underlying hardware. You didn't need to know what underlying hardware was there. You just needed to know that one ECU equals this, and you made your application calculations based on that. Now, Amazon has since moved away from ECU to a vCPU model where they expose now the underlying physical CPU that it's running on, so you get, a concept that you're more familiar with. We then talked about EC2 Instance Types. We talked about the fact that Amazon groups these instances into families to make it easier for you to consume and provision. We talked about micro, general purpose, compute optimized, GPU optimized, memory optimized, and storage optimized. And these were collections of instances. So if you had a workload or an application that was heavy on storage, you can immediately filter out all the other instances and take a look at those storage optimized instances for your particular application. We then went into a demo and I showed you where you can find these things in the Amazon Management Console. Finally, I hope this module was very informative for you, and I'd like to thank you for viewing.